Welcome, everyone. I think we're ready to get started. I know there'll be a few people continuing to come in, but I'd like to take a few moments just to welcome you and introduce our speaker today. So I'm Joe Helbley. I'm the Dean of the Thayer School of Engineering, and it's my privilege to introduce today's speaker, Professor Alexander Slocum, the Pappalardo Professor of Mechanical Engineering at the Massachusetts Institute of Technology. Now, first, a little bit of background on this lectureship. You're here today for the Visionaries in Technology Distinguished Lectureship. This is a once-per-year distinguished lecture series that we started about three plus years ago. So this is the fourth in the series, where we invite a single distinguished individual to spend a day and a half with us, sharing his or her work, talking about their ideas, and adding to the creative environment and atmosphere of the Thayer School of Engineering. The individual that we select each year is selected by a collection of the younger members, the junior members of our tenure track faculty, typically assistant professors, who are looking for someone who can bring their own creative energy to our conversations. It's a distinguished individual whose career has had significant impact in engineering, science, technology, policy, or in today's case, in the Professor Slocum, the world of engineering design. He is, in addition to being the Pappalardo Professor of Mechanical Engineering at MIT, a McViker Faculty Teaching Fellow and a Fellow of the ASME. He has over 100 patents and has helped develop 12 products that have received R&D 100 awards for one of the 100 best new technical products of the year. He's helped start several successful companies, and he has a passion, as we will see and hear in his remarks, for working across a broad range of problem areas and industries to help solve real problems and identify fundamental research topics where advancing design and developing real, tangible, usable products can help improve the world, improve the human condition. Alex was the Massachusetts Professor of the Year in 2000, and he is the recipient of many, many awards, which are in his printed bio. He loves sports, from scuba diving to snowboarding to marathons and iron distance triathlons, and I discovered, and this may be a first for a distinguished speaker at the Thayer School of Engineering, his day started with a long run with one of our faculty members in the pre-dawn hours of the day. He holds BS, MS, and PhD degrees from MIT, where he's been a member of the faculty since 1986. And I asked him earlier today if there was a single element that he would characterize as being a unifying theme throughout his work. And I'm paraphrasing, but he said essentially, engineering at the end of the day should be about fun. And I think we'll see that in his talks. His passion for changing people's lives through engineering design comes through loud and clear. So with that, please join me in welcoming Professor Slocum to the Thayer School of Engineering.
He forgot to mention high fashion. So
that was intentional.
Cool. So a little background. I could never do drugs as a young man. I couldn't afford them because I had a hot rod. So if you got a hot rod, you can't afford anything else. And I youngest years grew up in L.A., and my mom was a mathematician, worked with Norbert Wiener, and my dad as a nuclear physicist. I'm a study break. And I was always taught to think, never take anybody else's assumption, whatever, run the analysis, create, come back, close the loop, make your conclusions, and never take anything for granted, and always have fun and enjoy what you do. Because you were born, you're going to die. I like to think I'm over here. Click, click, okay? So that's how I live my life. I love sports, I love snowboarding. I love to absorb the mental energies of the young minds. So when I work with people who get excited, I get excited. So that's my job, is to help you get excited so I can have more fun. Okay, so let's do this together. Let's start with an assignment, and everybody here is probably ADHD++, so you can do a bunch of things at once. So I want you to be thinking about what would you do with $2 trillion in 8 years of time. No analogists, but just think of that. That's a central theme. Wake up, computer. And a lot of what I do is opposite. So I grew up as a skier, but now I'm a snowboarder. I was a weightlifter, bodybuilder type as a young man, and to run a quarter mile would be terrible because, you don't do that. But now I do the long distance stuff. And I work in renewable energy, and if I can get this thing to get moving, aha. But I'm also one of the parents of horizontal drilling for developing new drill bits to get all that oil out. Every last drop. So we can burn it and consume the planet. But you'll see, I think the oil industry is the savior of our planet. So ask yourself, how would you do that? Okay, let's see if we can get this thing going here. Aha, come on. Push it out. Well, it'll come out in a minute. So I want to introduce, I'll give you a bunch of stuff, and this is one of my more interesting, prolific-ish graduate students from long ago who really changed my life is Dr. Mark Graham. He started out as just a little baby undergraduate, and is a real prime example of reciprocity. He and I have taught a lot of stuff over the years, and he was a rap artist, still is a rap artist, and had it's called Journey of the Lost Souls. And from slavery to designer of medical devices. Or are we still slaves? To who and what? Ask yourself that question. So he's got a neat website, and I don't really like rap music per se, but I like the libretto. Isn't that interesting? That noisy, is the same as an opera. It's very interesting. So this is part of the keep that in mind here. So you can go to that site. But we have I'm on a semi-mission, and let me find that. Oh, look, maybe this is up and running. So this is my baby. You can see that. It's a new, directional drilling has been around for a while, but to get hotter and deeper, you can't because the seals melt. And I was asked, Alex, do you know any good polymer chemists? Because we need better seals. Because we're going hotter and deeper, and the seals aren't lasting, and you send a drill string down for 8-10 kilometers, and the seals die, and you got to pull that drill string up. So do you know any better polymer chemists? And I said, in the oil industry, you should know about intelligent design. The reason fish don't have propellers, God knew there'd be a problem with the seals. So I designed this directional drill bit that uses no seals, and it works better than the old one with the seals. Seals, no seals. Okay? You guys starting to get the picture here? So we'll put that one away. And so people often tell me that, and I'll play this at the end. See, this is the surprise. That, we can't do anything. We're all large corporations and all the coal. They want the money, and it doesn't matter. And I say, I can invent the new machines. It'll work, blah, blah. It doesn't matter. And this is how we think we're going to fix the problem. So you guys think about that. That's the other design challenge. You can have the best technology. You can even show it's economically viable. You can bring the horse to the water trough, and you can shove its nose in it, but it still may not drink unless. Okay, so remind me to play this at the end, okay? So let's dive into the actual talk now. And what are we going to do? What are we going to do? So, I love steak. I'm a hunter also. I love a fresh venison. But it's no good unless I got some potatoes and fresh cranberries and other food to go with it. Very few things in life, like I can say this because I'm married. I love kissing my wife. We've been married for 30 years, so I can say this. But kissing alone is kind of boring. I got some hugging too. Okay? So that's the nature of this thing is that you never should solve a problem. You should look at the system. And you can have much more joy and happiness and success if you look across the boundaries. And that's really where the excitement is. So how are we going to solve the energy problem? We're not. We're going to solve the energy, food, and water problem. Okay? And what we're going to do is, anywhere there's unhappiness, we're going to invert the problem and make happiness. Symbiotic engineering, reciprocity. You're not happy on your back, roll over on your stomach. Okay? So sometimes people say, and I was asked, Alex, what do you do? And I'm a mechano-psychotherapist. I listen for the whining and the complaining. I love that. Because then I'm going to make a machine out of it. All right? And have fun. So this talk, I do a lot of stuff, medical devices, machine tools, oil drill bits, everything. I just love gizmos, but I'm going to focus this talk totally on energy because I really am worried the planet is dying. I love snowboarding, and some of the glaciers I used to go hillboarding on in Canada are all gone. It's very sad. The barrier reef is dying, dogs and cats living together. And I assume you guys have all taken humanities classes, so you know that reference, right? Ghostbusters. And people often put a diagram of CO2 consumption in the Earth, and eventually it's going to look like that. I have 3 sons. My brother has 3 daughters, and so they grew up in the Britney Spears era, so this is what I worry about. Oops, will we do it again? We will not just be able to say we are innocent. That's the story. So we can't do that. But look, yes, dogs and cats can indeed live together happily. In my case, it's dogs and chickens, because we don't have any cats, because Debbie's allergic to them. So how are we going to do this? Well, we're going to go back to being a kid. And good old Dr. Seuss, and I hope you can read that. It says, think left and think right. See, reciprocity. Think low and think high. Oh, the things you can think up, if only you will try. So last night, and then during lunch today, I was one of the whines I hear from junior faculty and young people in general is you can't have a career and a family. You have to make decisions. And I say, nah, that's not true, because so this is actually real advice. Go get a sheet of paper. Think about the functional requirements of what you need to do for your kid, what you need for your work, blah, back and forth. And the moral of the story is you want to spend time and have fun and be creative. It's the same thing in both jobs. So get big sheets of newsprint, real crayons, lie down on the floor, and write your novel, design your gear trains, write the flow chart for your program with your kid, drawing animals and writing little poems. And your kid from 6 months, I was doing this with my granddaughter, I'm a new granddad. I was explaining to little baby Eleanor about, well, I'm working on this other oil field tool and how we're using wire to tangle things and everything else. You know what she said? She went, gah, flap, flap. She was very happy. And I was able to solve a gearing problem I was working on, okay? So you can have it, you can have your cake, ice cream, cherries, eat it, you can have it all, okay? So that's what you're going to do. So now, this is where this comes from. So in 2001, with a good friend of mine, LCE from Rutgers, we had planned a materials and design conference because I believe materials are actually the core root of innovation and design. You give me a new material that's never been used before, and I can make a huge new realm of machines. If I just have to deal with stone, I can do some stuff, but So anyway, 9/11 happened, very sad. Another guy, Shacker McGee, up at Toronto, is the other triad in this. Is our conference still on? He goes, out of 150 people, everyone is canceled. No one has said, I'm afraid. And I said, I hope you didn't give them their money back. He says, no, we already paid for the boat. We rented a Nile River boat. So we fly to Egypt, and then we went to Luxor, and then we were going to tuttle up to Aswan. And so we had half a Nile River boat, 150 people capacity, with 6 of us. I was the only white guy. Well, there was one Brit, but he was talking funny. So I got to bring my mom and my kid along, and we noticed, walking the back roads and everywhere, how wonderful the people were. And that's when it hit me. And I came back, and I love history. History is fantastic. And you can go back and look at the Vietnam War and the political issues and blah, 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 and the time spent and the money spent. You can bring that forward. And I did a prediction that we would spend the next 10 years and $2 to $3 trillion and get nowhere. So So I wrote all my representatives and everything, and I'm apolitical, by the way. This is just facts and history. And I got a letter back. I think it was Bob Smith, our senator from New Hampshire, who said, no, it'll be 2 or 3 years, 30 billion tops, and they're going to pay us back, and we'll have democracy and happiness everywhere in the Middle East. If you have 2 guns and you align them very carefully and you pull the triggers at the same time, you have 4 holes in your head or 2. 2, you are now better blessed. What? So anyway, and I was working in the White House 2 years ago as policy advisor for manufacturing, and I brought this little delicate point up, and I was told to go be quiet. So I'm going to raise it again. We're about ready to spend the next 10 years and another $2 trillion blowing shit up. So, do you realize that, and this is the numbers from back then, for $2 trillion in 10 years, I could have made 500 gigawatts, $4 a watt installed with storage back then, of renewable energy. That's the entire U.S. consumption. So what I had said was, we should be writing a letter that says, we don't know what we did to upset you, but we do know if we weren't there, we wouldn't be bothering you. So we're just going to extricate ourselves so we don't need any of your oil at all. No problem. And you know what? We know that you don't like other people there too. So we're just going to go ahead and invent this stuff and sell it all around the world. So no problem. And you know how Stalin tortured my uncle and he survived, but everybody else out of hundreds of people in his camp died? They put him and everyone else at one end of a room, and they gave everybody a wheelbarrow. And they said, fill your wheelbarrow with dirt, wheel it across, dump the dirt, fill it up, and come back. Back and forth. And it drove people mad because what they were doing made no sense. They would go mentally unstable and they would shoot you. My uncle was the last one standing. Isn't that interesting? There is no fear a human has more of being bored and irrelevant. Do you see the power of what we're talking about here? We're not going to hurt you. We're just going to make you irrelevant. Isn't that interesting what you can do with $2 trillion? What would it be for the carbon impact of the planet if in 10 years the United States didn't burn any more oil at all? Or coal, or natural gas? So instead of spending the next 10 years and $2 trillion blowing shit up, now it's about $2 a watt. So I could give you in 10 years a terawatt of 24/7 power without changing your lifestyle. Isn't that interesting? Just by, and you know what? The people who are in power of these giant mega corporations are out to crush you. No problem. You kids can make this hardware. We'll teach you how. You don't have to lose one drop of money. Isn't that interesting what you you guys say more? So here's how we're going to do it. So this is not, so that's the pep talk part. So this is the engineering. Now we're going to go to the engineering. So that was the humanities, the business, the economics, to get you riled up, excited, mad, happy. And now here's the geek part. So energy is the key to everything, and everything is the key to energy. But what I mean to that is, if you want to harvest the new energy systems, you have to have the new materials. But in order to get the new materials, you have the energy. So it's a circular logic. And in the end, whatever you do, you've got to have machines to make things infinitely cheap. So I've done a lot of work in semiconductors, a lot of bottle, we can make bottles and can tool. The cost of making things is basically zero. Just the cost of the materials when you make them in high volumes. Okay? So you'd invent the materials, the gizmo, or the machine, the thingy. I'll create the machine that makes this thing for zero cost. We'll put it out there and save the planet. Yay! So here's some examples of what we're going to do. I'm not going to read all this stuff. We'll get to the examples. Let's dive right in. So first thing, reciprocity. So when people say this can't be done, it's too big, you can't do all this in 10 years. Well, China grew from absolutely nothing to perhaps the world's largest economy in the last, 10, 20 years. Contemporary proof you can do it, period. Next thing, consumers as producers, the distributed energy, local grown food. How come, and we had a discussion with your dean, who's a really cool dude, by the way. How come you have vending machines and you don't have hydroponic houses where automation technologies are being used to grow the vegetables and blah, 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 and the economic study and yada, yada. So you could build your own little local microcosm for fresh fruits and vegetables and berries and things that then you can have in little local rooms, like, getaway places where people hang out to solve problems and munch, munch, munch good, healthy food that you've grown here by the machines you've automated and come up with. Huh? See, that's what you need to do, is get moving. Come on, let's get moving. We got birth, death. Click. Okay? You can do this. So, solar. The first thing is, you notice a lot of people, we're going to talk about solar thermal. I'm not going to cover PV here. I think that's a semi-ish solved problem, except for the storage, a little detail. So the interesting thing about solar thermal, you may have heard about, if you can harness the sun's heat, you can store heat, and then when the sun goes down, the physicists have to work on that thing. What do you do with the heat? And the conventional thing is, big, giant, manly tower, raw! We have an issue here. You see all this bright light here? So what they do is they have a whole huge field of heliostats, and they direct the sun's light up to here, and they have these little tubes with a little fluid going through. But, Apollo, he can't work. He's a union guy. He doesn't work 24/7. After 8 hours, he lets the sun down, lets the horses eat, and then it's dark, right? So you have these tubes getting heated up during the day. The sun goes back. Right? And you do that twice a day, and after a few years, your tubes blow out. No problem. If you give a mouse a cookie, we'll just put more steel and make the tubes bigger. But there's another little problem. In the morning, the sun is not so bright, then really bright, then not so bright. So, wait a second. If we make enough tubes to harvest all the energy from the really bright sun in the morning, we're not using a bunch of our tubes. So you see the problem? It gets compounded. But, we're going to make a big, manly solar structure, so we're going to make an even bigger tower. 100 screaming megawatts of solar thermal power, brought to you by the U.S. taxpayer. This is Ivanpah. So there's a little problem called physics, and the sun's over here, and the Earth is here, and the light comes, whoop, and it hits the mirror, then whoop, it starts to expand again. So when you work the physics out, anything over about 5 megawatts is foolish, because the receiver has to start getting so big to accept the cone of the light, but now it's so big, so it re-radiates. No problem, we'll burn natural gas to make up the difference. 4 guns. But a funny thing waiting to happen is any diver out there will let you know that below about 30 feet, you got no red left. And 60 feet, and all these people who like to go down, dive real deep are kind of stupid because you can't see anything. All the real action's up around 30 feet where all the color is. So I used to bring my own parts to the heat treaters, and anyway, molten salt is clear. And we can get rid of the tubes, and we have just a big tank. This is molten salt. This gray thing is a plate that separates the hot molten salt from the cold salt down here. And the sunlight is directed not by beaming it up into a tower where you have to have farmland, you're competing with farmers and so, but you find hillsides, and there are a lot more south-facing hillsides, it turns out, than just flat regions, and you blink the light right into here. Oh, you've got a cosine loss there, it'll never work. You do the math and you work out the total cost of energy, people. I don't care if along the way there's one little ouch. I mean, come on, I'm a snowboarder. I run into stuff all the time, but I still have fun. And this works really good. We're doing this with Masdar Institute. We've got a 20 kilowatt machine we're building. It's in Abu Dhabi. And then ramping up to a 1 megawatt machine. And then 5 megawatts, the steam tree people will tell you it's no good. You've got to have at least 100 megawatts to have a useful steam power. Ha! But the materials people have figured out, and our government has funded, and now GE has licensed, and train has left the station for supercritical CO2 machines. And this is actually this shown here is a 50 megawatt supercritical CO2 power plant. It's about a tenth the size of a steam plant because you do not need a condenser. Made possible by high temperature materials and a better understanding of the thermodynamic cycle for supercritical CO2. And so it turns out that these machines, if you look at the efficiency versus size, you don't really get a whole lot of increased efficiency beyond 5 megawatts. They are exactly perfectly tuned that you make a 5 We could probably push it to a 10 megawatt receiver here with its own little supercritical CO2 turbine here, driven generator. And now you have modular units that they can be made in a factory by robots doing this real fast, ship it out. And we can just now have everything modular, little containers that go bloop, 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 planting 5 megawatt machines. Pretty cool, huh? So that's coming. That is coming. Where are you going to put them all? It's too expensive. Do you realize how difficult the permitting is? And you know, there's environmental concerns because the answer is bomb them. So, you guys want to blow those goddamn environmental pansy asses up? That wouldn't be very nice. Blow up. Huh. Ooh. Turns out that the government's been blowing up shit. Oops, sorry, I used a bad word, blowing up. At these little places, White Sands, it's a missile range, and China Lake out in the west. And so we just Google eyes, and we find the places, the nice, appropriately facing hillsides, and where has been things, ordnance and stuff is and is not. And the four-wheelers and the people who like to go out in the desert on their four-wheelers to preserve the environment and rip shit up, they can't go here anyway. Well, first of all, it's too steep. Second of all, they may drive over something over here and get blown up. Okay, maybe it's not so bad. Anyway, we work numbers for 15% of the land we can utilize on these hills, and we cover just 30% coverage of it. And these two zones here, together, we can give you 40 gigawatts, 24/7 solar thermal power. How many people can that serve? Doon 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 bum bum bum. All of LA and San Diego, 20 million people, 2 kilowatts a person. Isn't 2,000 times 20 million 40 gigawatts? Yeah. Yeah. Isn't that funny? This is right there. 40 billion times 2. $80 billion! Okay, it costs $2 million per soldier. What is 80 billion divided by 2 million? Billion divided by a million is 1,000. 80 divided by 2 is 40. 40,000 soldiers worth of effort will pay for this. 40,000 soldiers paying for 40,000 soldiers for a year will give you all the 24/7 totally carbon-free power you want for all of San Diego and LA. Now you sit there and whine at me, it's too expensive. You see how simple this is? It really is that simple. It really is. Those hillsides are steep, and you know how expensive it's going to be to go on hillsides and put things? The history of Caterpillar Corporation is that Caterpillar was actually born out of a company in Washington State where they had these beautiful fertile hillsides that are steep like this, and they needed some kind of a tractor mechanism to go on the steep hillsides for planting and harvesting. The technology was invented 100 years ago, people. Oh. Well, I'll think of something to whine about because I really don't want to do anything because, you know. See how much fun we can have? I think we can have a lot of fun. And then offshore wind with pumped hydro. So the offshore wind is interesting because here's another, I have a further proof of intelligent design. Coastlines are beautiful, and I don't want to see any wind power stuff. So I'm going to just go ahead and make the Earth a distance of a marathon, with a curvature such that when you go offshore a distance of a marathon, you won't see the windmills. I think that's pretty smart design if you ask me, because I like to run marathons. So you put the windmill way outshore, and originally I started with spheres, but I realized in the future it's better and cheaper to do a concrete pipe. And basically, if we connect our network of offshore wind turbines just by these long pipes, and we work the economics out, it's quite good actually. What you're going to do is you're going to pump the water out of the pipe. So this is still true philosophically. When you have excess power, you pump the water out, and then when you need power, you let the water flow in through the turbine. It's just a pumped hydro energy storage system where they have a bunch of them in the Connecticut River. 100-year-old technology. So that's your battery. And there's another thing you can do. When you start looking at these offshore turbines, this is a study I did when I was in South Africa recently. We also have a problem with fish. And if you make aquaculture and it's near the shore, then there's all kinds of environmental issues. If you put the fish offshore far, then it's too expensive. The structures are too expensive. But if you have a bunch of structures offshore already, you can put fish farms around them. You see how we're combining the two? And this is really interesting. What happens is that if I take the people served per wind turbine, 1,000 people, it turns out that I can size this thing such that this will provide all the fish protein that those 1,000 people need for a year with a ball that's roughly 50 meters in diameter. Isn't that interesting? The way these numbers start to align. So that's what I encourage you guys to think about, is you take whiner A and whiner B, and you put them together to get good wine. Wind energy is a really interesting thing. So a few years ago, and I do gears and bearings, and I still do detailed part drawing. I just love machines. And a former student, good friend, blah, 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 was working with a venture capitalist, guy made a lot of money in software, and he says, I have this brilliant new idea for a wind turbine, and I want to save the planet, and blah, blah, blah. And Eric said, well, let's get Alex. There's some weird, strange gears things going on. And I looked at it and said, that's really clever. I've never seen anything like that before. It really was clever. There's a little problem called physics. And the problem is, we're going to do a little experiment here, further proof of intelligent design. Take your pen, writing instrument, put it to your head, this side. Now push. And keep pushing until it... Thank you. Isn't that interesting that the mathematician who invented the theory of... Now you turn it sideways so it's nice and wide. You push hard, it doesn't hurt. So the mathematician who created the design theory, or the mechanics of how to predict the stresses from high contact points, his name was Hertz. Who happens to be the same Hertz that frequency was named after. Literally, Heinrich Hertz. So the guy said, well, that's silly. Well, what do I invest in? I said, I have no clue. Let's go see where the money is. And notice that's a common theme of everything I've been talking about is where's the money, what's the cost? Because to do engineering just because it's cool is silly. Your engineering you do is absolutely of no value to anybody unless it can be of value to everybody. Please remember that. That's really, really important. It doesn't necessarily have to be of value today, but you have to see a path to it. Okay? That's really, really critical. So anyway, I said, let's go. I don't know, we went to NREL, we look at the big Pareto chart of where the costs are, and it turns out that 30% of the cost of wind energy was not in like the blades or the gearbox or any of that cool stuff. It was in the pole. So it turns out the physics of the pole is what's critical. And that is because you make the pole and then you've got to get it under a bridge, so it can only be 4¼ meters in diameter. And when a pole gets to beyond 80 meters, depending on the wind, you now end up with a pole that can be 3 to 4 inches thick at the base, and anything over 1 inch thick is you pay a big premium on the plates because the plate mills are really only set up to do 1 inch, sometimes 30 millimeter thick. And anything more than 1 inch, you have to do multi-pass welding. If you give a moose a muffin, you get a big problem, but no problem, I can fix it. Blah. So then you go back and you do the inverse problem, the reciprocal of it, which says, okay, now, what would happen if I designed a pole that only had a 1 inch wall thickness? Well, it turns out if the pole is now 7 to 8 meters in diameter, and you taper it up to the 3.5 at the top, you use 1/3 less steel than if you make the pole with a thick. Ooh, but you can't get it under the bridge. You can't make the pole in the factory in pieces and then ship it into the bridge and come over here and put the pole back together. You can't do it. I know what we'll do. We'll make the pole in the factory over here. We'll slice it up into other little pieces, and we'll bring it over here, and we'll put lots of bolts in it. How about we bring the factory to the field? So we designed a new machine. A lot of math went into it. This is a 1/8 scale we built the small scale first. It actually worked right out of the box. And we got really good funding. And what Eric figured out is the math behind how do you size these trapezoids that you will pre-cut and bring them in so we spiral weld the tapered pole, and we can make you a 150-meter pole if you want. 7 meters, down to 3 meters. And we can lower the cost of wind energy by 10%. That's past the tipping point because we use 1/3 less steel. And it's even more funny. If you look at the state of Maine, that thing over next door, it has about 6 gigawatts of wind potential on the ridges because that's the only place you have class 4 wind. That's a lot of power. You know, that's like 3 nukes, 2 nukes, depending how you do your energy. You know, that's a lot. No, it isn't. It's nothing. If you look at the vast forest regions that are no longer being used for pulp and paper, and people are wondering what to do, and there's no jobs, and I don't know what to do. You can't put wind there because the trees are in the way, and there's no hills and stuff. It's only class 3 wind. But that's 80 meters. If you go to 150 meters, most of the state of Maine is now class 4 wind, and the wind potential we can give you with that large pole at the same price as the short pole on the ridges is 60 gigawatts. 30 million people. So including New York, the entire New England region can be powered without even having to go offshore. Isn't that cool? I think it's really cool. And you don't have to mow down all the trees either. Trees can stay. It's actually not too expensive. It's cheap. No one wants to look at windmills. Yeah, they do, because these people routinely go into the forest and mow it down for a job, and they ain't got no jobs. They would like jobs. These people do not drive Lexus SUVs there in rural Maine. So we have the machine. It's rolling. We're located just outside of Denver. We have really good funding. We're moving. It's going to happen. This is happening. Low-cost wind power is happening. Now, I'm a big fan, by the way, of nuclear power. You'll see why in a minute, kind of. Because you need really good base load, and there's some places where you don't have good other alternatives. If we could do nuclear right, it would be good. Maybe they'll get fusion going in 20 years, which is what they said 20 years ago and 20 years before then. But that's all right. Bill Gates is on it. Maybe happen. I hope they're successful. But even if we did uranium in modest modes, in 100 years, we have no more uranium. That's it. And I don't know if anybody has ever seen a terrestrial uranium mine. People in Colorado don't like it. You get this thing called lead that comes with uranium. It's really a nasty mining process. But since the 50s, people have been working on polymers that will pull the uranium ions out of seawater. Turns out there's hundreds of thousands of years of uranium in seawater. We just got to get it out. And right now, they were about $700 a ton. I'm sorry, a kilogram, which is too much. Spot price of uranium, 50 to 100. And so the polymer friends have gotten the polymer better. And what our part of this project is, how do you design a machine that you can deploy offshore to get the uranium out? And it turns out you need about 4 kilometers of this seaweed in order to generate continually the equivalent of about 5 megawatts of power in your reactor. So you need a lot of this stuff. It's very dilute. So you can't afford to do it. Too expensive. You give a moose a muffin. So it turns out that, and this is all to scale, by the way. This is a real, this is conspiratorial or configurational, but this is all real to scale. 5 megawatt offshore wind turbine, and there are 4 kilometers of this rope going up and down, and it just goes down and up, down and up, down. And we've already simplified this, so this is already way old school, much simpler system we got. It's really cute what we did, but we can't show you yet, otherwise you all have to eat a lot of coffee. And so here's your 5 megawatts of uranium harvesting on a 5 megawatt wind turbine. So you can you're paying for this big structure here. You're not paying anything additionally in terms of structural to do this. So this is a free ride. So you're doubling essentially your energy potential for very little additional cost. Making offshore wind turbines now actually very economically viable. So that's a cool project. And it's a big one. That's why you give a moose a muffin for that one. Now, here's my little happy bit. And the secret was, this is the no seals. That's another happy story, fun time. But let's look at this. So since the 60s, I have a very good, dear friend, Dick Garwin, he's a very interesting physicist who wrote the code for the original simulation of how to design the first hydrogen bomb. Neat dude. He was the head of research at IBM for many years. And he's still very active down at OSTP in Washington. And I worked with him on the Deepwater Horizon project. Really spectacular guy. He took me aside and said, you know, Alex, since the 60s, we've dreamt of just burying nuclear waste in a deep borehole. Because that's where it came from the center, send it back to the center. He says, you work in oil. There's got to be a way to do this. Because the oil companies, remember, have the world's best technology for finding oil. But 90% of the time, they find nothing. So they're also the world's best companies for finding deep, 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 like many kilometers of nothing. That's where we'll drill the hole. And look at these numbers. If I have a 3 gigawatt plant, you use about 240 tons of, this is a spent nuclear fuel that comes out of it. And here's the operating life of the plant, the total waste produced, the borehole diameter, the emplacement zone, the number of branches, packing efficiency. And basically, with a very simple hole that I have technology to do now, that I could take all the nuclear waste over the entire life of a plant and just bloop, put it right into the plant. So the nuclear plant should be sited on boring geological features, not on the coast. Okay? So you can build nuclear plants and we can give you infinite amounts of uranium forever. And you know what? Right now, uranium is only producible in certain countries around the world. So if I've got a reactor, you know, I'm going to keep my spent fuel, I'm going to process it in plutonium just in case someone tries to shut me off from a supply. So I'll keep all this plutonium in case I need it. So we're also eliminating the motivation to reprocess the spent fuel into plutonium to burn, because now anybody can get uranium because it's everywhere offshore. And uranium by itself doesn't matter. So to the environmentalists, we're going to sell this by, do you realize that you are swimming in an ocean polluted with uranium? We now have this new structure to help rid the oceans of evil uranium. So maybe that'll work. So we're really excited about that. Now, the last thing is, because I grew up in LA, and I really like LA, and that's why I'm licensed to wear Hawaiian. Actually, I wear Hawaiian all the time, everywhere. You know, I was working in the White House, I always still wore Hawaiian shirts. I wore a tie with them. I had this one life form come up to me on day 2 who said, we have a certain dress protocol in this professional environment, and this is kind of really appropriate, and whatever. I said, dude, Armani suit, right? Yes. Egyptian cotton? Mm-hmm. Mississippi cotton, print from Tennessee. My wife designed and made this shirt by hand in New Hampshire. Why don't you come talk to me later? So, we got to save LA, and we're going to do it with afros. Yeah. This titles back to Mark Graham. The guy in the first picture. They may notice he's an African American. They may notice the little curly hair thing going on there. Important. He grew up sleeping in a bathtub because bullets used to come through the door where he grew up in Cleveland. His mother had him sleep in the cast iron bathtub. In LA, where I grew up, and my mother used to teach in Watts in the 60s when during the big riots. There's another Shaggy Dog story with that. But anyway, you have millions of people who essentially have no hope and are destitute. So here's what cycle this in. This is not a new idea. A lot of people have talked about it, but no one's ever really figured out how to do it. And I think we've figured out how to do it in the following way. So it was Mark who pointed this out to me. So I call this the Advanced Pumped Hydro Reverse Osmosis System. And Mark says, hey, Alec, that's pretty funny, man. That's APROS, dude. Like, oh! That's when he pointed out. Anyway, So intelligent design. It turns out that if you only have 5 days to create everything, because the 6th day you need to create Amazon and Home Depot and McMaster and FedEx to deliver this stuff, you got to hurry. So we're going to make the optimal head for pumped hydro systems like 500 to 700 meters, so you don't have cavitation off the Francis turbines, blah, blah, blah. Brandon can talk about that. It turns out that that's also the ideal head for reverse osmosis for the membranes, about 50 atmospheres or so. Huh. So if we co-locate these, Now check this out. Many drought-stricken coastal regions have mountains for upper reservoirs at this head height. In LA, the reason I would rather live in LA than San Francisco any day is because I can be on the beach one day and I can be up at Big Bear Lake the next day skiing. Okay? It also turns out, this little thing, so one of the problems with reverse osmosis is you make fresh water, but you get brine, and now one of the costs of reverse osmosis, you got to get rid of the brine, but if you pump the brine out, it's toxic and it kills everything. No problem. We'll have this long outflow line, which costs a lot of money, and we'll do some pumping to push the salt water out through the outflow line, and we'll slowly diffuse the brine. Look, the physics are also funny. To make an average of 2 kilowatts of power for 24 hours for you takes 20 cubic meters of water up at this height. To make you 500 liters of water takes about a cubic meter of seawater. So it turns out that the outflow from the power turbine, if you just dump the brine outflow from the RO plant, it automatically dilutes it, so you can just dump it right in the ocean. You delete the need for the long outflow. That symbiotic relationship just lines up perfectly. So that was our little aha. So now let's have some fun. Because this is old technology, by the way. There's no new technology required here. The Japanese at a plant called Yanbaru in Okinawa have proven you can have pumped seawater. Works great. Tastes great, less filling. And I apologize for the eye chartness. But look at these numbers. So if I say I want to serve 10 million people, LA, give everybody an average of 2 kilowatts, and I'm going to give you 500 liters of water a day, which is a lot, by the way. You only need an average, 300-400, and LA is now getting by with 100 to 200. No problem. And you run through the happy numbers, you get the following. I only need a lake that is roughly 3.5, let's call it 4 kilometers by 4 kilometers, that I'm going to cycle up and down 30 meters. And that's all. And you say, what are you talking about? Lake Mead in Grand Canyon is a huge giant lake. When they make the huge giant lake, because they're relying on collecting the water over a month and then slowly trickling it out. But this one will go up and down 30 meters every day. And basically the story is, your renewable energy systems that you'll put out in the mountains, in the desert, wherever you're going to get them, the excess power pumps the water up, and then at night and the times when you need the power and you can't get it, comes back down. So that's the daily cycling through this level of this lake. And we do the ROI calculations, again, with very generous numbers for the cost of power. You see I'm putting in $2 a watt each and $3 a watt for the pumped hydro, which is actually quite a lot of money. I'm being generous. I'm even giving you 15% a year gross on operations and maintenance. And it turns out it's a 15-year ROI, which is about what a normal power plant is budgeted at. Pretty funny, huh? So it's very doable. In theory, let's look at practice. Let's start with Lanai. And if anybody knows Mr. Ellison, you may want to tell him this, because they have a real problem with fresh water there. And we also looked in Oahu, all the islands. And what is this? This is the Afro coefficient. See, we're having fun, right? And what this is, I have this really, really brilliant student, Maha. She's really good at a lot of stuff. She's working on the uranium project. She's really good with maps and digital analysis. And the Afro coefficient is, if you are at least 500 meters in elevation, you can have opportunity for being colorized. Otherwise, we'll just keep you, boring. And then we divide by the distance from the sea. So the closer you are and the higher you are, the brighter color you are. Red being, yeah, this is really hot area for this. And turns out that for Lanai, We have energy potential. Look at these numbers, 80 gigawatts a day. If you go to the main island, to Maui, we could give you 2,000 gigawatt hours per day. And the lake sizes are relatively small. So it's really trivial. And then we have a paper in review on this, and at the end of the paper we put this philosophical question. I think it's our duty when we publish technical papers to not flinch from asking the philosophical questions, and not just, this paper describes epsilon, which we've achieved by gaining delta. Therefore, it is boring, and everyone will be asleep by the time they finish reading it. The paper points out, we have to ask the question, if you know 500 years from now, what do you want to happen with your bones? Would you rather your bones just sit there, or someone maybe builds a lake on top of them in honor of you, and that lake going up and down now means that your bones are blessing no carbon, and power for your people, jobs for your people, happiness for your people without hurting the planet. What do you want your bones to do in 500 years? Because the argument on some of these lands are, those are sacred grounds. No problem, we'll just keep burning carbon, we'll kill everybody. That way we can all be on sacred grounds together. Yeah! Because most of these people drive SUVs. Okay, so that's something very important. As engineers, we need to reach out and work with the sociologists, the lawyers, the politicians on how do we bring this system to reality. Remember I mentioned earlier about, if you don't do anything for a high cost, that's the costing it down, that cute little thing I said earlier. It's not just money, it's actually how do you work with real people to implement your system. Really critical. Okay? I think I have to speed up. So it turns out California, Malibu and San Clemente, dude, plenty of opportunity up there in the mountains. No one lives there. Scrub. Oh, and if the limousine liberals there say, you can't do that. No problem. I have really good friends in Mexico, some very wealthy families in Mexico. A lot of things happen in Mexico because the wealthy families say so, and if you don't like it, that's all right. You'll be in the desert somewhere. It's, tortilla food or something. Anyway, it turns out that in Ensenada, in Tijuana, they have even a bigger, more fantastic Afro coefficient. And you know what? I'm not going to build a wall and have minefields and fierce dogs to keep all those damn people out of my country. Yeah. I'm just going to make a fantastic energy fresh water industry where they're not going to want to come up here because this is where all the opportunity is, and we're going to sell the water and energy to the gringos. And that's actually what we're going to be doing. This is what we are moving forward on. So, Morocco. So now my European friends, there's a program called Desert Tech, where they wanted to make all of North Africa just, the bastion of renewable energy for Europe. And then some political instability things happen. Oh, we're not going to invest our money over there. Oh, no, that's too big. No, that'd be a waste of money. Terrible. No, we can't. We have to have guaranteed investments. And then it killed it. Boom. No problem. And I did a few little calculation, and it turns out the cost of the refugee crisis and fences and stuff is about 3 to 5 times the money that if they would have invested in Desert Tech, they could have clean energy, and those people would have jobs and opportunity, and maybe they wouldn't have this political problem. See, we're not the only one to lock on those things. All right, so that's an opportunity, and then United Arab Emirates, because I do a lot of work in the UAE with the solar energy thing, and we could give you all the power and fresh water you want, powered by renewables. And in January, I'll be in Israel and Jordan working with my friends on, there is a thing called the Red Sea, Dead Sea project, where they wanted to have a big pipe to go from the Red Sea down to the Dead Sea, which is about 450 meters lower, and then have a Afrosic system there for fresh water and power. They weren't really sure, and it will cause environmental disaster in the Dead Sea, and back and forth. And my buddies over there say, you know what, Alex, it looks like, and we showed them now, you can build the Afro system here in the mountains, either above Aqaba or Eilat, and provide power for basically all of Israel and Jordan, power and fresh water. Wouldn't that be cute? Hey guys, you can always blow each other up later. Let's just build this first, and then you can get back to blowing up. And maybe you won't even need to blow each other up. Now, speaking of that, the country with the biggest potential resource and the biggest population and the biggest current contemporary challenge, Iran. Turns out that on the Caspian Sea, above Iran there, we can do an Afro system and give power and fresh water for over 100 million people. because Tehran is chronically short of water. Chronically short of water. This was brought out to me by Hassan. Who is he? He is Maha's significant other. But he's the wrong flavor. She is, I always mix these up. He is Shiite, he is Sunni. Yet they're the significant others. I say, what gives? They say, we don't talk about that at home. We have enough good things and happy things to do. Isn't that interesting that when it gets down to people, there's no problem? And then he said, yeah, but it's over 100 miles. This is over 100 miles. I don't know, that's kind of long, Alex. I said, there was this dude named Mulholland in the late 1800s in LA, and without hydraulics, LA got all its water from the Owens Valley 100 miles away through the aqueduct. It's the same project. And he was like, interesting. So I contend that, and in the paper we issued this challenge to our Iranian friends, dudes, you could be the saviors of the Middle East with Afro technology. Because the Iranians are fantastic engineers. You go back to Persian days. I mean, truly, remember, does everybody remember their history of Persia? I mean, it's really spectacular. Well, my ancestors were killing each other. These guys were building amazing civil works. So history will, and I hope, repeats itself. So I'm almost done burbling. I hope we're having fun. So when I was 40, and when you're 40, you get a special exam, and my doctor, she pulls off her veterinary glove and says, boy, you're in a world of hurt. And I was good and spherical. I used to love packing it in. And then I had to cut it out. That's my chainsaw. And I just love doing these long-distance races because endorphin flows. But check this out. Number of super sugared foo-foo coffees per day, 10 million, very conservative number. This is why I want to get this energy thing in a personal note, because we've been talking about 1.21 gigawatts, right? Okay, the extra cost of the foo-foo coffee, $5. Everybody know what I mean by foo-foo coffee? Like Star Wars with Mega Ground Squirrel and all that stuff. 500 extra calories. Total gigacalories, energy value of all foo-foo coffee consumed per day, 5 gigacalories. Tons of body fat per day, 714. That means that there are 24 18-wheelers of body fat being hauled out every day from the foo-foo coffee. I used to love my coffee with 3 creams and like 5 sugars. And what I did is I took about 6 months and I cut it back a little bit every day till now the only thing I can drink is black coffee. It's fantastic. It has to be good black coffee, though. And wind turbine size, cost per turbine, electric power demand, number of wind turbines, statin sales per year to make up for this, which, by the way, this is no good. Do cholesterol drugs really do any good? Business Week, not really. Wind turbines per year that can be bought with statins, 3,000 per year. Years to wind energy goal, if no foo-foo coffee and no statins. In 50 years, you could basically provide all our electric power. Isn't that funny? I think it's funny. And we'd be like, having more fun. So how are we going to do this? Education. I propose that K through PhD be solved with real problems that really matter. And this is inspired, my wife has been a FIRST robotics coach for, a dozen years now. And for interesting about FIRST robotics is you have engineers, but you have animators and business people. They involve the whole community of life forms. And it's also a RoboCup soccer. They want to have by 2050 a robotic team that challenges. And every year they post the code. So everybody starts even so that everybody goes up. And I call it facing the sun. And watch this. If in high schools you say teams are going to build solar panels and deploy them. And the winner is who collects the most energy over the year. So one option is just put the solar panel out there and that's it. The other option is, but if you conserve, good heliostat, you'll collect more and you'll win. Oh, but the other thing is that your solar panel has to be online so everybody can see it. So you know what? I'm going to just hack into your system and your solar panel, I'm just going to point it away. So you better make damn sure that you've got a good software geek with good internet security, because we've got to also teach that. And I believe that by having and then the panels that work stay up until they die. So when you graduate from high school, you can still have in your resume, look at my solar panel, it's still working. I really engineered it. Ownership and passion instead of, I'm going to learn how to fill out my oval better than your oval. Education. Okay? So that's the challenge. We need to do that. We need to work together, design the system, get it in our schools. I'll be running my little class this fall to start this. When I was working in Washington and I proposed this system, I was told, that's too ambitious. We need something that we can have deployable right now that we can show with metrics that the actual summation of the learning process has been achieved through the parallel life form optimization process that the Department of Education has approved and certified. It was like literally like that. I was like, really? No, I'll go do it myself. So we're going to do it, and this is the more details on that. And now let's get back to how can we actually do this, because politicians control everything, big companies won't let you do it, blah, 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 blah. So we're going to put the world first. It's a little poem that I did the first part at, and Mark smiled and said, all right, you guys can't jump and you can't rap either. I'll fix it for you. I can say that because that's what Mark said. And you don't want him coming after you. He's a cool dude. Remember, he designs medical products. He'll design something in the software that has your social security number detected, and if you made fun of him, that's it, baby. So we'll play that rap for you in a minute, but look at the words. And think about all those people in Los Angeles who have guns, a lot of guns, who have no respect for you, the rich dude in your limo, who they want a job. And they want ownership, they want a good life like you've got a good life. And if you don't give them a good life, they're going to take it. And you can't run anywhere. I suggest everyone reads The Bonfire of the Vanities. They're coming. And I remember when they grabbed my mom and pulled her out of the car and they were beating, and most of the when it's a hospital, her coworkers up. Remember I told you she worked in Watts, she was a math teacher? And you know what they did when they pulled my mother out of the car? Big guy said, that's Mrs. Slocum. You leave her alone. She treats us well. Because my mom always held everybody, if I get a little choked up, she died much later, to high standards. And you have to hold yourself and your students to high standards, or we will have no planet. Nothing. So, the future is ours. If we engineers don't work with the politicians and the business people, we are threaded. We are intercoursed. You guys probably thought I was going to use some bad language. So this is, we are going to launch the revolution through teaching, popular culture, and engaging the passion of millions of voters who have a lot of guns. And the fact that economically it just makes sense. And we can still save the planets. Let's see if it'll play.
Action no longer passive to massive to stagnate. Reaction we see the moment, accelerate, penetrate with force, remove miles from desperate situations, renew energy jobs will lay the foundation. Question, research, guess, test, analyze with the passion, because building what we create is the prevalent high passion. Our faith is in our control, so let's stay hands united. The only way before this in a world divided. Mother Earth don't care for flattery, so saying that we love her won't spare some tragedy. Words don't make the difference, we've been treating her badly. Ain't no one should forgive us, now we need a new strategy. The most important calculations are those who will save nations, like building wind plantations instead of more gas stations. And seeking new destinations in space is complicated. The Earth is worth saving from what we initiated. It's time to double levels in land, water, and sky. It's time to come together. It's time to solarize the polar caps. Our melting sea levels are on a rise. Surprise, the superstores still haven't opened our eyes. Some scientists theorize and politicians decide. The man that's not at fault, so they gamble with our lives. Let's get off the sidelines and show we're not psychotic, insane. No wait and change on the same plan. Periodic debate. Fate is a state of a consequent generation. Reversing the complications requires more impatience. No time to be wasted. This fight it's not symbolic. The cash drop and tighter relationship symbiotic. To put the word action no longer passive to massive
research guests that's analyzed with a passion. Cause building what we create is the prevalent high fashion. Our savings in our control, so let's stay in hands united. The only way we'll fold is in a world divided. Father Earth don't care for flattery, so saying the level won't spare us from tragedy. Words don't make a difference when we run out of raggedy. Burn and fossil fuels when we got windmills and batteries. With the word.
You guys get the message? So let's get out there and do it. So, any questions?
Started a little late, ran a little bit long, and we have a reception for everyone with Professor Slocum outside. So what I'd suggest is we take no more than 3 brief questions, give you a chance to answer them broadly, and then we'll all move to the reception and have an opportunity for individual conversation. So any questions?
Yes? Oops.
I'm curious, out of all the different regions of the world that you've worked in, is there any particular region or country who's actually embracing all these ideas and technology that you presented today?
Interestingly enough, that's why I'm headed to the Middle East. And I'm doing more of my work actually in the Middle East than most places. But it's going over real well in the United States too. And then in Chile, I have some good partners there. And I've just started this program with my friends in Mexico. So when people see the actual numbers and the simplicity of the technology, it has not been a hard sell to get people at least interested in starting now on, let's dive into the next level of detail of applying it. This stuff is only 2, 3, 4 years old, most of it. But I really haven't run into, the only restart I needed was on the offshore wind turbines with the underwater storage. That's still too many unknowns and too expensive-ish. So I said, okay, I can't do it offshore, then onshore, what do we do? This is where we're going to, Maine was 60 gigawatts thing.
I'm curious about, since you like crazy, this is kind of a crazy question, and it's a crazy thing that I've heard, and I want to know what your opinion is. So if you do the calculations and you take a land area much less than the size of the Middle East, with solar power and half a terawatt for 100 kilometer by 100 kilometer, 200 watts per meter square insulation, you could power all 14 terawatts of the Earth. And so the only thing people say that will change is you'll take all the deserts in the Middle East, which now are pumping oil, and they'll become giant solar panels, and some oil pipelines will just be doing electricity and other things that will go to the rest of the world. And so the Middle East will basically still power the whole world and just devote their land area to that. Do you think that's crazy?
Well, here's why it's crazy. Well, it's crazy because you don't need to do that. You need a lot of water too. That's where the Afros thing is. So for all of LA and San Diego there, the solar power for the Afro system just comes from putting it on the roofs. And there's plenty of local available land area for the PV and wind to power all those Afro systems. So you don't have to do it all in the Middle East.
Yeah, but
Now,
people are crazy and have inertia. They'd rather go, instead of going to the gas pump, they'd rather go to whatever pump now it is, that has still got all the same oil pipelines, all the electric pipelines, and just keep the same lazy lifestyle of doing nothing in the U.S. and getting everything from the Middle East.
No, we're making it cheaper. So soon, within the next 5 to 10 years, I still want to drive up to a gas station and have as effortless as my gasoline car for my transport. I will not give that up. And if I have to burn oil to kill the planet, too bad. No problem. Because if I'm an engineer that's worth my salt, I will design a system to give that life form happiness. So Project Better Place had a pretty good idea, but they didn't understand mechanics properly. That's why Project Better Place failed. They were greedy and they really didn't understand mechanics. And I tried to explain it to these guys when on one of my trips to Israel, and they wouldn't listen. But that's all right. They're out of business, basically, but we'll do it right this time. And I'm not being flippant when I say that. So we can have our cake and ice cream and eat it too. We can. And I do believe that the Northern Africa part will become the energy conduit for most of Southern Europe, because that's fine. We can do that.
One last quick question. Charlie.
Do we also need to work on energy efficiency, or is that just too hard and it's easier to just have much better supply?
No, I think you're absolutely right. I didn't talk about that here. That's the real low-hanging rabbit. I mean, it's better than just a low-hanging fruit or a fat rabbit. It's like the combo. Because the payback for that is a couple years. So, and I think you're seeing more and more people are just doing it because it makes economic sense. But we need to do more. Yeah.
So please join me in thanking Professor Slocum.